This is question 6 from the SACE Stage 2 Physics course companion from Chapter 1.4, Relativity. A moving muon is measured by scientists to have a lifetime of 5.05 microseconds. The lifetime of the muon in a frame of reference of the muon is 2.2 microseconds. We need to determine the speed of the muon. So here again we need to make sure that we have a good understanding of which time is appropriate for which frame of reference. So the moving muon is measured by scientists to have a lifetime of 5.05 microseconds. That means that in that frame of reference, the spatial coordinates of the muon are changing, so they are measuring t in the lifetime. That the lifetime of the muon in the muon's frame of reference is the frame of reference where the spatial coordinates are fixed, so t naught is 2.2 microseconds. So here we have this one we've measured. That's the frame of reference where the spatial coordinates are changing. So this is 5.05 microseconds, and this one is 2.2 microseconds. What we need to do is first determine our value for the Lorentz factor, then rearrange that to find our value for c, not for c, for the speed of the muon. So here we have the Lorentz factor is t on t naught, which will be 5.05 divided by 2.2, which ends up being 2.5. Now this algebra is a little bit tricky for finding v, so we have the Lorentz factor is 1 on v squared takes c squared. So we can first move the 1 on to the other side to get this expression. Now we can just get rid of the square root, so that'll just be 1 on Lorentz factor squared is 1 take v squared over c squared. Now we can, that 1 take at the front of the right hand side, we can shift to the other side, to the left hand side, to make it, and that is v squared on c squared. Now we just multiply through by c squared. And finally, if we square root both sides, we'll get our expression for v. So I'm going to add an extra step in here. So this is correct, but it looks a bit messy, so we can just rewrite this as the square root of 1 on squared multiplied by c. So now if we just substitute our Lorentz factor value, we get our final speed in terms of c rather than having to include it in our calculation. So now this will just be 1 on, what was our Lorentz factor from before, 2.5 squared times c, and if we put that into our calculator, we should get 0.92c. And that's it. So this one's a little bit tricky because we have to first work out which time is measured in which frame of reference. Again, the easiest way to do it is to think about the frame of reference where the spatial coordinates are moving. That'll be t, and the frame of reference where the spatial coordinates are fixed, and that's t naught. And the algebra here is a little bit difficult, but once you do it 2 or 3 times, it's not so bad, and you learn to skip a few steps. But at the moment, this is probably needed for the first few that you need to do. And that's it. So it looks fairly hard, but it's actually not too bad. It's just the algebra, which is a little messy.